Hi, good morning, everyone. I hope you can hear me all right. Okay, so thank you for spending your time today with us. We're going to spend the next half an hour or so talking about the hydrocarbon liquid and gas flow computer that's available from ProSoft. Let's talk about flow metering. So I know that some of you are very experienced in this field, but for those who have never done flow metering before, here's a really quick 2-minute summary of what it is. It's essentially the technology and the science behind accurately measuring the transfer of hydrocarbon fluids according to established industry standards, okay, between two parties or between two systems. The fluids that we're talking about here are liquids and gases. And the liquids are the usual suspects, right? Crude oil, propane, butane, and so on. And gases involved are a mixture of up to 21 different components, okay, including nitrogen, methane, CO2, hydrogen sulfide, okay, and all the common gases that we get from an oil well. Okay. So we're not talking about the measurement of water. Okay. Water has different properties. They do not expand or compress in the same way. They're not affected by temperature or pressure the same way as hydrocarbon gases are. Okay. We're talking strictly about hydrocarbon liquids. And well, gases, of course, it's mostly nitrogen in the air. So you can generally measure most gases. Right? So the technology used involves measuring the pressure and temperature in a flowing pipe. And the critical instrument in any flow measurement system is the flow meter itself. Okay? So I've shown here a differential pressure transmitter. That's typically used to measure gases. We've got other technologies available like turbine flow meters, ultrasonic flow meters, pitot tubes, things like that. So I won't get into the detailed technology behind this, but this is just a quick introduction to what flow metering is about. Application areas involved. Everything from upstream to downstream. So we're talking about well pads, we're talking about drilling rigs, offshore drilling rigs, FPSOs, chemical treatment plants, tank farms, okay? Anything like that. Anything that involves, again, like I said, the transfer of hydrocarbon fluids, okay, from one party to another. Now, here's the value proposition that we're talking about today. And this really is the crux of the entire webinar this morning. Okay? We're offering a value proposition to oil and gas customers, okay, who are under, as you know, cost pressure these days, under profit pressures because of the oil price. Okay? We're offering an alternative architecture. So traditionally, to measure hydrocarbon fluids, we need to have a flow computer. And depending on the number of streams and number of meters that we need to monitor, we might have to have more than one flow computer. So the flow computer takes in field I/O, which are your pressure readings and temperature readings and so on, calculates the amount, the volume as well as the mass, okay, of hydrocarbon being transferred across the pipe, and sends that data over to a PLC, okay, or a programmable automation controller, or PAC. The PAC makes decisions on how much to throttle the flow control valve, whether or not to run the pump, and so on. Okay, so those are the sort of the automation functions of a flow metering system. And generally, all this data needs to be transmitted back to a SCADA host back in the main control room as well. So there's a communications function typically performed by an RTU. So you have multiple systems, you have communication requirements between all these systems, and a lot of integration effort, okay, just to achieve the basic flow metering and control and reporting functions. So the value proposition that we're offering here is to use your existing PLC or PAC to do both flow metering, well, not both, all flow metering, control, as well as communications. Okay. So we're talking about an integrated system compared to a traditional separated system, performing the same functions. So with an integrated system, you have higher capacity at a lower cost. So an AFC generally runs in the ballpark of $3,000. We've had customers who had to buy traditional flow computers, for a cost of anything from $10,000 to $40,000 just for a flow computer. And typically, traditional flow computers have limited capacity as well. Each flow computer might support 1 to 2 meter runs. I've seen up to 4 meter runs in a flow computer. The AFC, on the other hand, supports up to 16 meter runs. And you can have more than one AFC in your PLC. So we're talking, in practical terms, near unlimited expandability in the AFC system. As long as your PLC can supply enough backplane power to the AFC and supply enough I/O to the AFC, you can have as many as you need to fulfill your project requirements. So we're talking about a significant reduction in cost, with no reduction in functionality, and this is highly attractive, especially in current times like this, when all oil and gas companies are under profit pressures and cost pressures. Especially in large sites where you have multiple streams, for example, multi-well pad sites are a perfect example, where you have to monitor multiple streams at the same time in the same location. The AFC really comes into its own. And AFC is also tightly integrated. So using add-on instructions, we're also using the same PLC I/O modules that you're used to for the PLC itself. And you're using the same PLC programming language as well to control your AFC. There's no integration required with third-party systems. So one of the typical challenges is that every AFC, after computing, it needs to pass the computed values over Modbus to your PLC. So you need to keep track of which registers to use. You need to go through the entire pain of setting up and troubleshooting communications with your flow computer and so on. Well, all that's gone now with an AFC because everything is integrated into the same backplane. So we're talking lower costs and lower engineering costs. The potential customers and applications for this, we already mentioned some of them. So we've got offshore rigs, we've got floating production and storage vessels, any OEM that's making metering skids for these customers, that's a potential customer as well. Gas pipelines, so obviously you need to measure the amount of gas flowing in the pipeline at any one time, to measure, for example, a product being transferred to a third party, to measure for leaks, things like that. So all this can use your AFC. What's shown in the picture here is an LACT, a least automatic custody and transfer unit. So in a nutshell, what it is, it's an automatic system that delivers the product, for example, from a tank farm into a chemical treatment plant, in batches. So all these batches are automatically archived and measured and recorded, and can be used for billing purposes, perhaps at the end of the month. The AFC from ProSoft is currently available in these platforms. For Rockwell Automation, we've got them in the Control Logics form factor, Compact Logics, as well as SLC. The PLC 5 one has been discontinued. As you know, the PLC 5 platform is a legacy platform. So support for that has been discontinued. For Schneider Electric, we've also got the AFC supported on the Quantum or Unity platform. And this month, we're happy to announce that we are launching a new enhanced AFC for the Control Logics platform. The other platforms will follow shortly. But available today is I think available this month, later this month, is the enhanced AFC. Right? It still features 16-meter channels. Each meter channel supports 4 streams. So in some situations, you have customers using the same meter for different products. Okay. So the EAFC module here supports 16 meters and 4 streams per meter. Okay. It supports all the standard calculation methods accepted by the oil and gas industry, and it also has secure data archiving, okay, are stored in non-volatile RAM. So our records are automatically stored either on a daily basis or an hourly basis, on a batch basis. So all this can be controlled by a ladder logic from the PLC. Okay. So it's up to 60 days worth of hourly records, okay, and as you can see, up to 1,440 daily archive records as well. Okay. So we have lots and lots of memory, lots and lots of archives. Currently supported measurement standards are as listed down here. These are the standards that's generally accepted in most customers. Most of them coming from the American Petroleum Institute, API, as well as the American Gas Association, AGA. Okay. So those of you who are involved in the metering industry will find these to be very familiar standards. But those of you who perhaps are new to this, here's just again a quick introduction to what AGA3 is. So AGA3 is a method of measuring fluids, gases really, such as natural gas and so on, across an orifice plate. So if you look at the middle picture here, you can see an orifice plate, which is essentially a metal plate with a small hole, okay, that's smaller than the diameter of the pipe itself. So as gases flow across the small hole, you get a pressure drop. And if you imagine that, and just by measuring the pressure drop and by measuring the pressure and temperature of the entire flow system, we can very accurately calculate the amount of gas, okay, that's flowing through that small hole. And that's AGA3. AGA7 is a set of equations that describe the flow of natural gas through turbine meters. So this is a different technology. Turbine meters are essentially propellers. So obviously, as more gas flows, you get greater number of pulses being generated by the turbine flow meter. AGA8 is a way of accurately measuring the compressibility of a gas. So different components obviously compress at different rates. So by very accurately measuring the gaseous components in your flow, you can actually mathematically calculate the compressibility of the fluid. And these standards involve some very, very complex formulas. So here's an example from ISO 5167. So they measure the amount of volume flow rate, okay, in standard cubic feet per hour, flowing across an orifice plate. Okay. There's a lot of different components that go into it. So all these are automatically computed by the EAFC, okay, and fed into essentially a totalizer mechanism. So you don't have to memorize any of this. All this is automatically done by the EAFC. There are some other features that's typically required by a flow computing system. For example, like I've already mentioned, you need to have an accurate archive of records. You need to have an audit trail of events as well, okay, such as alarms, such as changes in calibration, even records such as when the EAFC itself was powered up. Okay. All these are available in a non-volatile RAM, non-volatile fashion, within the EAFC module. There's even a weights and measurements lock on the EAFC module. So if you look to the right-hand side, you see this little switch over here that's marked as a W and M lock. That lock prevents users from changing the calibration or settings of the EAFC module without authorization. Okay. So that's again a standard requirement from most flow metering systems. The EAFC itself comes with software that's available for download at no cost. The EAFC Manager allows you to configure meters, configure parameters of your sites, and so on, as well as configure archive settings. So, for example, to view as well as trigger archive recordings. Okay. So I won't go into the exact all the details of the AFC features here. That's all going to be available on our website. Another typical requirement from the oil and gas industry is the ability to report all of these measurement functions via Modbus to a SCADA system or to a perhaps a local HMI system. So the AFC itself comes with a built-in Ethernet port that supports Modbus TCP, so you don't have to purchase a separate Modbus TCP module to perform this function. So I've already mentioned that AFC is extremely tightly integrated with the programming environment. So, for example, the add-on instructions for the Logix 5000 as well as the Studio 5000 environment, just have to drop in this AOI block, and essentially the AFC is functional. There's also transmitter calibration and verification functions built in. So you have records of exactly which instruments were calibrated, how they deviated across compared to an accepted reference, and so on. So all that is available as a record. So in short, it is a summary. These are the takeaway points from today's webinar. The AFC allows you to expand the footprint of your PLC and PAC to not just do controls, but to also include flow metering functions. So you're doing your customers a favor here by reducing its overall total cost of ownership. You're replacing some very expensive flow computer modules with an AFC that's not just low cost, but also tightly integrated into your PLC system. We've got an enhanced AFC that's going to be available this month. If you want more information, you just type ProSoft Flow Computer Solutions into a Google search, and your first hit, right, should be a landing page on the ProSoft website. And this landing page, once it opens, I'm going to demonstrate here. This landing page will show you a summary of all the oil and gas solutions that's available from us. What products and what solutions are available. So as you can see there, there's a video on flow computers. There's a short write-up also on LACT systems. There's even a summary of some of the wireless communication solutions that you can use to further reduce the total cost of ownership of your oil and gas systems. Okay? So you can save on cabling. You can expand the remote accessibility of your system by hooking it up to the Internet of Things, right? So you can use the cellular technology to make your measurement system available, okay, in a secure manner from anywhere in the world. So have a look at that. And if you have any questions, you can always contact us. There's contact options available at the bottom of that webpage. Okay, we're always happy to hear from you. So that brings us to the end of a very short and very brief webinar. If you have any questions, we'll stay online for the next couple of minutes. Please feel free to type it in, and we will be happy to answer those questions online right now. Yes.
There's a question. Difference between MVI56E-AFC and MVI56E-AFC.
Okay, that's a really good question. So the EAFC features support for the latest measurement standards. So some of these standards have been updated. So we've updated the EAFC to support that as well. I believe we've got enhanced storage volumes also. And we've also improved the weights and measurements lock mechanism. It was a little bit fiddly, the old one. And then in the new one, we've got a better mechanism. The EAFC also has support for Modbus TCP now, which is Ethernet based. The old one had support only for Modbus serial. And yeah, we find customers are using Modbus TCP a lot more now. So we've allowed for that now in the EAFC. Good question.
Okay, another question has come in. Do we have any application note and reference for the applications installed?
That's a great question. So I think we're as guilty as most vendors in not doing really well with our application stories. We do have 2 of them on the website. So if you just go to psft.com and look for success stories, in fact, I think I can do it right now. So if you go to news and events and success stories, okay, we've only written up 2 of them, unfortunately. We do have many more installations than just 2. If you go to liquid and gas flow computer, you'll see that there are 2 solutions down here. One of them talking about the PEMI pipeline, which I believe was in Peru, South America. Anyway, the story's in there. The other one is with Petrobras, the Brazilian national petroleum company. We've got a huge installed base in the US. Unfortunately, we haven't written any stories on that. And I believe Queensland Gas down in Australia also uses the EAFC a lot. Yeah, so technical notes are also available in the website. So if you go to the website and just search for EAFC, okay, you'll find obviously download links for a lot and the summaries for a lot of these products. But you'll also see further down data sheets and so on, and a bunch of, give me a second. There should be a bunch of technical notes available, reference guides, so you can see there's a bunch of reference guides and technical notes available from the EAFC.
Okay, that's another question. What is the connection from the EAFC to the meters, etc.? Hardwired or high-level communication?
Hardwired. So the EAFC itself does not come with I/O. That's a really good question, by the way. So compared to a standard flow computer, standard flow computers have built-in I/Os, just enough to fit, what the capacity of the flow computer. The EAFC itself doesn't come with I/O. So what you need is to have standard PLC I/O, and the EAFC reads the I/O values from there. So you would wire in your pulses from your thermal meters. You wire in your pressure transmitter and temperature transmitter readings into analog inputs cards, and all that will be transmitted to the EAFC via the backplane.
Next question, any calculation on ROI?
Unfortunately, no calculation yet. So as you can imagine, the ROI calculations are different for different customers. Yeah, but that is a straight up cost savings already. Comparing a standard flow computer with an EAFC, so you do get immediate ROI just from hardware savings alone. Okay. That's some great questions. Thanks for that. And obviously, talk to your local ProSoft distributor, talk to your local ProSoft rep. We'll be happy to answer any questions.
All right. Next question: who are major competitors for EAFC?
That's a great question. So there's plenty of brands out there that make flow computers. Yeah, and don't know if it's right to mention brand names over this webinar, but really any, I guess just do a Google search. Anyone making a flow computer is a potential alternate solution supplier. Yeah, so lots of competitors. Yeah, it's probably a little inappropriate to mention brand names here. Yeah, but yeah, and anyone who's in this business would be able to rattle off a dozen different brand names. I guess, yeah, talk to your local oil and gas customer. Find out what flow computer vendor they are traditionally using. There are a few key big players, but the market in general is quite fragmented. Typically, customers use the brand that they're used to. Yeah. All right. So, so if there aren't any more questions, then we'll call it an end here. Thank you very much for spending your time today with us, and hope to see you at the next webinar. Have a great day then.
Thank you. Bye.
Bye.